Okay, so we're given a circle radius of 3 feet. We're told that it's centered 4 feet off of the ground, and we're going to track around. P is going to be like our starting point, and we're going to track it around as it goes around the circle, as the circle is rotated all the way around, at least for one period or one time around the circle. Our goal is basically to come up with some function that represents this situation. So I'm going to try to graph this over on the right-hand side, and then we'll talk through exactly which trigonometric function we're going to utilize. So some values that we care about. 1, the center here is going to be at 4. And then that lowest point, P, looks to be right around here. Well, remember our radius of the circle was 3 feet. So if we start with 4 feet from the middle, and then we subtract 3 away, that starting position is actually going to be at 1, right? We start 1 foot off of the ground as we start moving around the circle. All right, the highest point we're going to get to, we're also going to need that as well. Well, we start at the 4, and then we're going to add 3 to that because the radius is 3. And then it looks like the highest value we get to would be 7 feet off of the ground. All of that's going to be kind of important as we go through this. All right, the next thing is, let's think about our moving around the circle. Basically, as we move around the circle, we're going to start at the lowest value. So we're going to start at 1, and then we're going to proceed and we're going to increase all the way up until we get to 7. Then as we keep going back around, we go all the way back down until we get back to 1. So I think if I visualize this, we're going to start at 1. We're going to work our way up till we get to 7. We get to 7, then we come, this is a little bit sloppy on my graphing. We're going to come back all the way down, and we're going to end 1 revolution back here at 1 for a height. Okay, well, that kind of reminds me of a sine or cosine graph. But what I'm going to do is, I think we want to use the cosine graph, because remember how that starts and ends. It's going to start at an extreme. This is just the basic cosine graph, comes down, and then comes back up and ends at that extreme, at the highest or lowest point. So the normal cosine graph starts at the highest and ends at the highest. Our graph kind of starts at the lowest and ends at the lowest. So we're going to account for that, but I think we want to use cosine as opposed to sine because sine starts in the middle. All right, so as we think about building this up, okay, let's think. We want cosine. We're going to have a, some multiple out in front perhaps, times cosine. And then if it was a difficult one, it would be have a b, x minus c on the inside, and a plus d at the end. Now, I don't think ours is going to be nearly this difficult. And why I say that is because A has to do with the amplitude. Of our graph. B corresponds with a change in the period. From beginning to ending. Now, reading through this, it doesn't mention anything about the change in the period. It doesn't say anything about the period at all. So I'm going to ignore B for right now. All right. If it had said something like, oh, it takes 30 minutes to go all the way around this circle or something like that, then that would be a change in our period, or they'd state the period. In our case, they don't mention anything about the period. What about C? Well, C corresponds with a horizontal shift. While we could have used the sine graph and thought about it as a horizontal shift of some sort, this one kind of starts how the regular cosine graph does, right? The cosine graph has the highest value at the y-axis. Ours happens to have a lowest value at the y-axis, so it kind of starts at either that highest or lowest value. So I'm going to ignore the C part. Finally, D, what this corresponds with is a vertical shift in our graph. All right, so as you can see, normally we kind of have the middle of our graph is at the x-axis. The middle of our graph doesn't appear to be at the x-axis. It appears it's been shifted up. All right, so let's think about that. That's also going to correspond with, sometimes we call this the midline of our function. So really, we've simplified this. We need y equals a times, cosine of x plus d. So really, we need to find a and d in our case. So let's work on this. Let's find A first, A being the amplitude. What we can do is we can think of this as the difference in the highest y value and the lowest y value divided by 2. All right, so the highest y value looks like we go all the way up to 7, and the lowest y value is going to be here at 1, so we're going to do that difference, 7 minus 1, and then we're going to divide that by 2. All right, so that's going to be 6 over 2, which is 3. Technically, it's going to be the absolute value of this. 3 is going to be our amplitude, A. We have to be a little bit careful, though. In our case, as we build this up, we're going to have y equals 3 cosine of x plus d. Because ours appears to be inverted or flipped upside down from the original cosine graph, we need to account for that and say instead of starting at a highest value, we start at a lowest value. It's been flipped upside down, so we're going to need to utilize a negative out here in front of our 3 to be a vertical reflection. All right, the last thing we need to find on ours is d, which, like we said, that's a vertical shift. We can sometimes call this the midline. And the midline is basically the average of the highest and the lowest y values. All right, so the average of the highest and lowest, we said the highest was 7 and the lowest was 1, so 7 plus 1, and we take their average, we're going to divide that by 2. We're going to get 8 over 2, which works out to be 4. All right, and as you can see, we've moved everything up 4. If we were to draw a nice line going right through the middle, hopefully that 4, y equals 4, cuts our graph in half, right? There's half of the graph above and half of the graph below that line, y equals 4. So final answer, as we get done here, we're going to go y equals -3 cosine of x, and then plus 4 hanging out here at the end to be that vertical transformation. And that's going to be the graph, that function that gives us the graph of this situation about our circle 4 units above the ground with a radius of 3 that's rotating around. So I hope this helps out. Good luck as you're working through these. Draw the graph, get a picture going, and know what each one of these components means for that graph. Good luck.